While discussing areas under curve y equals to fx, so we had a curve y equals to fx, and we discussed area function, where area function was the area under this curve from a to x. So we came to know that this was fb minus f of a, where f dash x is f of x. Okay. So basically what is happening is this. Example we discussed was the function y equals to x square. Okay. So if you took fx to be x cubed by 3, you noticed that f dash x was 3x square by 3, which is x square, which is fx. And in fact, if you take fx to be x cubed by 3 plus any constant c, then the derivative of f will be 3x square by 3 plus 0, because the derivative of a constant function is always 0. So this is going to be x square. So what we notice is that I am differentiating capital Fx and I'm getting small fx. So now we introduced a new symbol, and that is known as indefinite integral. Okay, indefinite integral of fx. So that is actually the opposite of differentiation. So what is the sign of indefinite integral? This is an elongated s. Okay, fx dx. Okay, so this is equal to, now what does it mean? It means that this is going to be some capital Fx plus c. Okay, now this is indefinite integral of fx. What does it mean? It means that when we differentiate fx plus c, we get small fx. That is, it is equivalent to d by dx of fx plus c is equal to d by dx of this integration. And we are going to get nothing but f of x. Okay. So this is indefinite integral. Now let us see some example. For example, we want to calculate indefinite integral of x power 4 dx. Okay. So what is your fx? Fx is x power 4. Now, if I choose my capital Fx to be x5 by 5 plus constant c, we can notice that f dash x is 5x4 by 5 plus 0, which is x4. So this can be written down as x5 by 5 plus c. So the indefinite integral is to be evaluated in such a manner so that the derivative of the answer should give me back the function under consideration. So standard indefinite integral of certain functions which are of importance economics are, for example, if I'm calculating x raised to the power n dx, the indefinite integral of x power n, this will be x power n plus 1 plus c, provided that n is not equals to minus 1. And you can see, because when we differentiate x power n plus 1 upon n plus 1 plus c, we will get n plus 1 x power n divided by n plus 1 plus c. Okay, so this is the first observation. Now this will hold for any real number n where n is not equal to minus 1. And what if n is equal to minus 1? That means if I have a situation like this, this is going to be log with the base e mod of x plus c. So these are certain observations. What is integration of e power x dx? That is going to be integration That is going to be e power x plus c, because derivative of e power x is e power x. So with the knowledge of differentiation, we can actually revert back to a formula in integration. Similarly, this is going to be a power x log with base e. Why? Because when we differentiate a power x, we get a power x log a. So I have a constant here. So this is going to cancel the constant in the numerator. So we'll get back the function. So these are few important indefinite integrals which are of importance in economics. Now, some rules of integration. Okay. So we know that, if fx and gx, okay, are integrable functions. So basically, first of all, functions have to be integrable. What does it mean? That it means that we should be able to find an indefinite integral. That means we should be able to find a, capital Fx such that this thing can happen. Okay. So suppose Fx and Gx are integrable functions and K is a constant. Okay. So if we talk about integration of fx and gx with a plus minus sign, so we should be able to separate these, separately calculate. And this follows by the rules of differentiation, because we already know from differentiation that, d by dx of any two function, capital Fx and capital Gx with plus minus sign in between, is equal to d by dx of capital Fx and d by dx of capital Gx. So basically, integration is a reverse process of differentiation. So since in differentiation we have these rules, these are going to follow in integration also. Okay. Second is, if I multiply my function with a constant k, for example, if I have k gx, or we can have k times gx, it should be k. K can be taken out. Integration of gx. Okay. And we do not have any rule, any simpler rule like this. For example, suppose you want to say that this is equal to integration of fx dx times integration of gx dx. We do not have any rule like this, and this is wrong. Please do not do this. And you must be knowing that why this is not true, because we already know that d by dx of fg is not equals to d by dx of f times d by dx of g. This is also not true. We have a product rule in differentiation, which is not this. And similarly, this will not hold in integration. In integration, if we talk about mathematics, we will have a integration by parts rule, okay, which is not very much used in economics in this course. So we should be knowing simple rules of integration, okay. So for example, if we want to find out integration of x cube plus, integration of 3 power x. So we have a function fx and we have a function gx. So just separate them using the rule. And this is going to be the sum of these two. So x4 by 4 and 3x by log base e3 plus the constant. So that is how we apply the rules for indefinite integrals.